Let's evaluate limit x tends to 0, x minus sin x cos x divided by x cube. We'll be applying L'Hopital rule, and we write sin x cos x is 2 times sin x cos x by 2. That's the advantage is that I can write this expression simply as sin 2x and it will be easier to differentiate. So we can write this as half of sin 2x. Observe that as x tends to 0, 2 sin x cos x tends to 0. And as x tends to 0, x tends to 0, so the difference tends to 0. And as x tends to 0, denominator also tends to 0, so it is of the type 0 by 0 form and L'Hopital rule is applicable. When we say L'Hopital rule, if we apply L'Hopital rule and if we are able to compute the value, then we are able to compute the value or the limit. Let's apply L'Hopital rule and try to compute the value or the limit. So we simply differentiate the numerator and we simply differentiate the denominator. Denominator is x cubed, so we simply differentiate the numerator and then we differentiate the denominator. That's what L'Hopital rule is all about. So this limit equal to limit x tends to 0, derivative of x, that's just 1. Once again, derivative of x, that's just 1, and then minus half, that's just a constant. Derivative of sin u dx is d dx of sin u is simply equal to cos u du dx. That's the formula we got. And so derivative of sin 2x is cos 2x, and then derivative of 2x. Derivative of 2x is just 2. What about the denominator? We differentiate x cube to say that derivative of x cube is 3x square. Okay, we can cancel 2 out, and when we do so, we get 1 minus cos 2x by 3x square. Observe that as x tends to 0, 2x also tends to 0, and so cos 2x tends to 1. And 1 minus cos 2x tends to 0. So numerator is still tending to 0. What about the denominator? Denominator is also tending to 0. So it is still an indeterminate form and it is of the type 0 by 0 form. So we apply L'Hopital rule once again. Apply L'Hopital rule. Once again. So the limit must be equal to limit x tends to 0. You simply differentiate the numerator. Once again, we simply differentiate the numerator. So d dx of 1 minus cos 2x, and then differentiate the denominator. So d dx of 3x square. That's equal to limit x tends to 0. Derivative of 1 is just 0, and then derivative of cos 2x. We know that d dx of cos u equal to minus sin u and then du dx. And then du dx. Once again, derivative of cos u is minus sin u and then du dx. So derivative of cos 2x is minus sin 2x, and then derivative of 2x with respect to x, which is just 2. How about denominator? 3, that's just a constant. Derivative of x square is just 2x. Okay, we can cancel 2 out, and we did it. So we are left out with limit x tends to 0, limit x tends to 0, sin 2x by 3. Oh, I forgot x, sin 2x by 3x. As x tends to 0, sin 2x definitely tends to 0. 3x also tends to 0, it is still an indeterminate form and it is of the type 0 by 0 form. Of course, we know the formula that limit x tends to 0 sin x by x is equal to 1. But let's apply L'Hopital rule. We are continuing applying L'Hopital rule. So d dx of numerator and then d dx of denominator. When we differentiate the numerator, we obtain derivative of sin 2x is cos 2x and then derivative of 2x, which is just 2. Derivative of 3x is just 3. Limit x tends to 0, we write it as it is. As x tends to 0, cos 2x tends to 1, so the ratio is simply equal to 2 by 3. And that's the final answer.